Title of this section is complex numbers. Okay, 3.3. Complex numbers. I don't have much an intro for this one. Besides, it's 3.3 called complex numbers. Fantastic. All right. So, blast from pasts. Ready for this? What's that? 8. Great. What about this? Square root of 8. 2 rad 2. Fantastic. Okay, now, if you don't remember that it's 2 rad 2, how can you go figuring out that it is 2 rad 2? Factor trees. Beautiful. Okay? You factor tree it. 4 times 2 gives you 8. You break up 4 to go 2 and 2. There's your 2's that come out. So 2, and then this 2 stays inside. 2 rad 2. From yesteryears, yes? Okay. Probably from Algebra 1. All right, same way with 24. Now, as you get older, okay, maybe your first algebra teacher taught you to just go about, if it's even, cut it down by 2's, and then you circle like 3 groups of 2's or whatever, okay? I'm going to tell you to start thinking about your perfect square numbers that go through into that number. That way it goes faster, okay? So what perfect square, 1, 4, 9, 16, goes into 24? 4. Okay. 4 and what, Miss Peterson?
8.
Ooh, try again. Too big. 4 and 6, yeah. Okay. And 4 goes 2 and 2. So you get 2 square root of 6. No need to break 6 up, right? It goes 2 and 3, which means it just gets put back together to 6, right? So if you have to break it up to C, that's fine, but if you don't, that's cool too. What about this guy?
4 rad.
Nope. Nope. Can't. You can't do it. Not yet. You used to say no solution. You used to say can't do it, impossible. You used to say all these things. Used to. Today, we changed that. All right, and that's what this is about. Okay, this is what's called imaginary numbers. All right, now before I get into everything up here, let me start it with this. Okay. The fact that they are called imaginary numbers does not mean they don't exist. Okay? It doesn't mean that they're imaginary. They're not like your imaginary friends you used to have. Okay? Or you still have, no offense. Whichever way it goes. Okay? They're not like that. They do happen. They do exist. There's a reason why they put the term imaginary with it is because they happen in a very specific instance. Okay? They happen whenever you have a negative square root. Okay? They happen when you have a negative square root. Now, to clean that up and to allow us to still work with it because of all the rules that change since your square root is negative, instead of working with the negative square root, they change it to an I, a variable. Okay? They change it to that. Okay, so this definition is kind of written backwards. So you have I equals the square root of negative 1. If you square both sides, then I squared equals negative 1. Okay, now you're going to learn, we're going to do a lot today. That part right there is the most important thing to remember. I squared equals negative 1. All right, you remember that, you'll get through about 90% of these problems, because what it's eventually going to turn into is problems you've already learned how to do. It's just there's going to be an I in it and out. That's it. Okay? I squared is the most common power that shows up besides 1. And I squared equals negative 1. All right, and we'll get into that. That's the hard part of this lesson right here. is this stuff here, okay? Pure imaginary numbers are numbers that come from square roots of negative real numbers, okay? So that's what the imaginary numbers are. They come from negative square roots. So now to answer everybody's burning question, how do you do it then? It's really simple. Step 1. You write it as 2. Instead of the square root of negative 27, write it as the square root of negative 1 times the square root of 27. Split them off. You can do that. That's legal. Okay? We just learned the square root of negative 1 is what? I. Just I. All right? So that means we have I square root 27. Now take 27 and factor tree it. So how does 27 break up? 9 and 3. And 9 goes 3 and 3. So the way you write this, pay attention to this now. You go bring your number out first. So 3. The I goes second. And the square root goes third. See, it's just exactly like you simplified square roots in the past, right? Okay, the exact same thing. Factor tree it down, bring out your pairs. The only difference is since it started off as negative, you have to have this I to signify that it used to be a negative inside that square root. Okay? That's the only thing that's different right now. Does that make sense? Great. So the next one. Same way. Break out. Make it negative 1. And 2/16. Square root of negative 1 is I. And then factor tree 2/16. This is where, knowing your perfect squares comes in handy. All right? Whenever your teachers told you like to divide them down by 2 and 2 and 2, this is an example one that would take forever. Okay? So what I do is this. I go by my perfect squares first. Okay? So I start with 4. And if it goes by 4, I do 4. Now it may go by 4. Actually, I know this one goes by 4. Right? Yeah. Okay. But it's 50, but there might be a bigger one. So now since I know it's even, I skip over 9. Okay, at least I'm going to skip over 9 on this one. And I'm going to go to what? What's next after 9? Perfect square. 16. Perfect square. So do 2/16 divided by 16. Does it work? No. Okay, 13.5, no big deal. All right, now obviously 25 is not going to work, yes? Okay, so we can skip over that. What goes next? 36. So what's 2/16 divided by 36? 6. And is 36 a perfect square? Yeah. So you see how much faster you got there? Okay. Now, if you did it, what was it, 4 and 54? Right? Yeah. If you did it by 4, that's fine, but you got to keep on breaking 54 down, because 54 breaks down also. Okay, so you're not fully done yet. Okay, so you can do it however you want to, as long as you get there. 6i. We're at 6. I'm just trying to show you guys the most, in my opinion, most efficient way to get there. So this kind of starts where you go into your operations. Okay, and you go into your operations. Now, there is a rule that I have not said yet, and the rule is this. You cannot give me an answer in any of these problems that has a I power bigger than 1. You cannot circle an answer in any of these parts with I power bigger than 1. If your I power is bigger than 1, you have to change it. And how you change that is what we're going to get to the rest of the day. Tagging it along with normal operations. Ignore that up there for now. I want you to focus on what I'm going to write here next. I'm going to do it in blue. Negative 5x times 3x. What is that? Negative 15. Watch your signs. X, what? Good. Good job. So proud. Okay, now going back to the black. What's negative 5i times 3i? I squared. Good. Negative 15i squared. See how they're the same? Except your variables are different. Okay, so here's the nice part. I's act like variables. They do. The whole way through. Okay? Whenever it comes to combining like terms or multiplying or whatever, it comes just the same as variables. Negative 5x times 3x, negative 15x squared. Negative 5i times 3i, negative 15i squared. Here's the difference. We wrote down at some point in here I squared equals what? Negative 1. Okay? I squared equals negative 1. And since you have to change the power, because you can't circle that, because your I power is bigger than 1, you have to go one step further. Negative 15 times negative 1. Okay? And then you do that. So negative 15 times negative 1 gives you okay. Next example is the square root of negative 6 times the square root of negative 15. The rule that says you can multiply these insides together only works on positive numbers. Okay? Which means it does not work on negative numbers. Hence here. So your first step is to do like we did with the very first problems we did today. Pull your I's out. Alright? So change both of them from negatives, square roots, to I's. So I square root of 6 times I square root of 15. Now you can put these guys back together, except I times I is I squared. You do the fronts first. And then you multiply the insides together. 6 times 15 gives you 90. Break 90 up. That's easy enough. 9 and 10. Then you got 3. I squared. We're at 10, except you can't circle that yet because your I power, okay, which means I squared is I squared is negative 1. So negative 1 times 3, negative 3. All right, next up. Adding these guys, subtracting these guys. All right. The I's act as variables, yes? You know how to combine like terms? Hopefully, yes. That's all you do. Okay. 5 plus 2 gives you what? 7. 7i plus 4i gives you 11i. Not 11i squared, right? Just 11i. Okay? But that's literally it for that one. Mm-hmm. It's not I squared. It's not a FOIL problem, right? Because you got a plus in the middle. See that? Not a FOIL problem. It's a plus problem. Okay, just like down here, not a FOIL problem. This is a what? Subtraction problem. So what do you have to do with this negative sign here? Distribute it through, change the signs, right? Or at least that's the way I do it. So you go 4 minus 8i minus 2 minus 4i. Change your signs on the back end. But then you go through and combine like terms again. So you got 4 minus 2 to give you 2. Negative 8i minus 4i gives you negative 12i. And you're done. Because they're not I squareds here. See that? You don't change them to I squares. So you keep them like that. Alright, FOIL this guy. So first times first. 6 times 9 gives you 54. 6 times 2i gives you 12 what? 12i. Good, Camp Cricket, your eyes. Now, negative 8i times 9 gives you I. Good. Okay, be careful here. Negative 8i times 2i gives you I squared. Okay? So now, you got a lot of cleanup to do, right? This used to be a real easy cleanup. Combine like terms in the middle, that'd be it. Okay? You got a little more work with this one now. Okay? So now you have the I squared. I would clean it up first. Okay? Which means it's, whoops, come on screen. Which means this is a negative 1. Okay? Now, to save yourself some writing, if this is going to be a negative 1, and you're going to times it by this 16, negative 16, that's going to become what? Positive. Okay? So save yourself that step and just write it straight up. So you get 54 plus 12i minus 72i plus 16. Now you go through and get your like terms. Good. 54 and 16 should be 70, yes? 12 minus 72 give you minus 60 and the I. Okay, now where this does come up quite a bit, okay, where these do come up quite a bit is something called the square root property. This is what we're going to work with pretty much going forward with I's. Okay, besides the little intricacies of this lesson specifically, when we move on, this is where it's going to come up the most. All right, we need to solve this. Okay, and the way you do it is this. You subtract 64. Like that. All right. Now, how do you undo a square power? Anybody know? You take a square root. Hence, square root property. Makes sense? Yeah. So you take a square root to both sides. And that cancels the square on the x. Okay? You keep the x there, equals. Now, you see how that turns it into a problem from before? Right here? All right, square root of negative 64. So if you want over to the side, go like that. That becomes I, and this becomes what? Square root of 64, guys. 8. Okay, so x equals 8i. Okay? Now, that is not your full answer. Okay? To get your full answer, I got to explain something else to you that you may or may not know. Whenever you solve an equation, you're trying to do what? You're trying to make the equation be equal. That's why it's an equation, right? Okay? And you're trying to find the numbers that will get that done, yes? Okay, you're trying to figure out the numbers that will make that equation be equal. Okay? So, x squared equals 25. What number will make that work? 5. Obviously. 5 squared is 25. Is that it? No. Because what else will do that? What other number squared gives you 25? No? Just single number. Single number being squared times itself. No? Negative 5. Because what's negative 5 times negative 5? 25. There are 2. Okay? Chances are, whenever you're solving these equations, there's going to be 2. So to make sure you know that there's 2, you got to put this. Plus or minus. That's the answer. Okay? You take a square root, you have to remember to put plus or minus when you're solving. Okay? If it's already in the problem and you are simplifying, you don't need it. But if you got to take it to solve an equation, you do. Okay? That is a very specific difference. Okay? Make sure you catch on to that. Alright, now, the last thing we have to do is figure out all the other powers of I. And yes, you're going to know all of them. From 1 to as big as I want to go. Okay? Now, I'm going to start this off, instead of trying to explain it since we are running short on time, I'm just going to write these out, okay? So I equals I. We know that. I squared equals what? We know this one too. Negative 1. Okay, the rest I'm going to tell you. I cubed is negative I, and I to the 4th is 1. These 4 powers you need to have memorized. Okay? I is I squared is negative 1, I cubed is negative I to the 4th is 1. I, negative 1, negative I, 1. Because if any of these other powers show up in a problem, you need to reduce them down to these. Because these are your first power of i's. Everybody see that? Okay? I know this is on... I'll get there. Okay? But like I said, the main one, no, I squared. That's the main one. You know that. Like I said, 90% of the problems you'll be okay. Now we're going to talk about the other 10%. Okay? Now, once again, because we're running short on time, I'm just going to tell you these 4. But I'm just going to do it backwards just to really mess with you. Can someone let Miss Steppen in, please? That's 5, 6, 7, and 8, your powers. What do you notice? They're the same. They're the same as the first 4. Right, they're the same as 1, 2, 3, 4. 5, 6, 7, 8. Now we're dancing, right? Are the same as 1, 2, 3, 4. 9, 10, 11, 12 are going to be the same as?
You said what?
9, 10, 11, and 12. 1, 2, 3, and 4. Okay? Where am I at then? 13, 14, 15, 16 are going to be the same as? 1, 2, 3, 4. Where am I at? 17, 18, 19, 20. Same as? 1, 2, 3, 4. They all repeat. Okay? For reasons we're not getting into. But they repeat. I, negative 1, negative I, 1. I, negative 1, negative I, 1. You know how I memorized it? I just said the whole entire rest of the day. I walked around like a little drone. I, negative 1, negative I, 1. I, negative 1, negative I, 1. Okay? You say it for about 15 minutes straight, it'll be there. Okay? You know what else I did? Whenever I knew I had a test coming up, I almost walked in like muttering that to myself. And it was the first thing I wrote down. Okay? Now, how do you figure out, let's say without, obviously we know the first few powers. Okay, we can figure it out from there, all right? What if we did I to the 96th. It's a little big, huh? Hmm? You sure? Okay. Let's see here. Let me change the screen. Hold up. Okay. Whoa. They can all go. Everybody got all that down? Yes? Okay. Windshield wiper. Erase everything. So what I say, I said 96th? Right? Okay. What are they rotating in? Groups of?
4.
4.
So it's 1.
So divide it by
4.
4. Okay? 96 divided by 4 gives you what, Mr. Savannah? 24. Okay? Now, it was a power of 4. Or it was divisible by 4. Let's go with that right word. Divisible by 4. I to the 4th was 1. Which means this one is 1.
Repeat what you just said.
Since you divided 96 by 4, and it came out even, divisible by 4, right? That means it's you know how you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That bottom row is all divisible by 4. That whole bottom row would be 1. So with this, just way out there. Okay? Good. What about I to the 237th? You divide it by 4. Now what does that tell you? What does that tell you? 237 divided by 4 gives you what kind of decimal, Ms. Peterson? 59.25. Remember what you divided by. You divided by
4.
4. Which means your decimals are going to be in what? They're either going to be 0.25, 0.5, 0.75, or they're going to be even. So when you go to divide it by 4, there you go. Makes sense. I equals I. And whenever you divide and you get 0.25, that equals I. Like this one here. Okay? So go back one number. Say it was I-236. When you divide by 236, you're going to get an even number, right? You're going to divide it out evenly. It's going to be 59. So that next power up is going to be in your first row. See that? So if you get a decimal 0.25, it means you have a first power of I. Decimal 0.5, second power of I, which reduces to -1. Third power of I, 0.75, reduces to -I, divides it even, remainder 0.0. See that? Means you have 1. That's how you figure it out. You divide it by 4, you look at the remainder. Okay? Pretty good. Alright. Your homework assignment is page 176, 1 through 8, 11 through 14. This is due tomorrow. You do not have a lesson check tomorrow. Okay? This is due tomorrow. You do not have a lesson check tomorrow.